In level 4, you will be using the same properties from levels 2 and 3, but you will apply them in trickier problems. In this example, it says find k such that f of x equals some function with k's in it, has a factor x minus 2. So we're solving for k, and we know that this function has the factor x minus 2. If it has the factor x minus 2, that means that 2 is a 0, and it also means that the function can be divided by the factor x minus 2 with a remainder of 0. Okay, so we're going to set up synthetic division. We put the 2 in this little box, and we list the coefficients, which would be 1, negative k, positive k, and 2. And we, just like when we do normal synthetic division, even though it has variables in it, we're going to follow the same steps. So we bring down the 1, we multiply the 2 by the 1, and we get 2. And now we add negative k plus 2, and we just write the expression, negative k plus 2. Then we multiply 2 by that expression, and we get negative 2k plus 4. And then just like before, we add k plus that expression, negative 2k plus 4, and we get negative k plus 4. And then we multiply, and we get negative 2k plus 8. And now, this is a very key component to this problem. We want this remainder to be 0. So if this is a factor, the remainder has to be 0. So we're going to set up an equation where the sum of these two must equal 0. So I do 2 plus negative 2k plus 8 equals 0. And I solve this equation, negative 2k plus 10 equals 0. Subtract 10 from both sides, and we get negative 2k equals negative 10. Divide both sides by negative 2, and k equals 5. In this next example, we are given one of the zeros of the polynomial. Since it's a third degree polynomial, the greatest number of zeros it can have is 3, so there could be 2 more. And we're supposed to find the sum of the remaining solutions. So we need to find the other zeros of the polynomial. If we know 3 is a 0, we can do synthetic division. So we put 3 and then list the coefficients. 1, negative 8, 16, negative 3. Bring down the 1, multiply the 3 times the 1, and we get 3. Add negative 8 plus 3, we get negative 5. Multiply 3 times negative 5, we get negative 15. Add 16 plus negative 15, and we get 1. Multiply 3 times 1, and we get 3. Add, and we get 0, which we should, because if we already know that something is a solution, the remainder should be 0. So now to write this in factored form, we know that 3 is a solution or a 0, so x minus 3 is a factor. And then from this expression right here, we get our other factor. That would be x squared minus 5x plus 1. And you always want to check and see if it's factorable, and in this case it's not. And since we can't factor this, we need to figure out when this equals 0 and find the other solutions, we need to use the quadratic formula. So the quadratic formula, remember, is the opposite of b plus or minus the square root of b squared minus 4ac over 2a. So in this case, a is 1, there's your a, b is -5, c is 1. So we get the opposite of b, the opposite of -5 is +5, plus or minus the square root of b squared, -5 squared is 25, minus 4 times a, which is 1, times c, which is 1, over 2a, which is 1. And we simplify that. And we get 5 plus or minus the square root of 21 over 2. And that actually represents two solutions because of the plus or minus. It's 5 plus radical 21 over 2 and 5 minus radical 21 over 2. So we have two additional solutions besides the 3 that we already knew about. And we're supposed to find the sum of the remaining solutions. So we want to add those two solutions together. So now to find the sum, we're going to add 5 plus radical 21 over 2 plus 5 minus radical 21 over 2. And these already have common denominators, so we can just add the tops. And we get 5 plus radical 21 plus 5 minus radical 21 all over 2. And the square root of 21 minus the square root of 21 cancels. We can add the 5 and we get 10 over 2, which is 5. So the sum of those remaining solutions is 5.